name is Rob Blue. I'm an environmental specialist here at LAX. For my section, we're going to watch a short video. Then I'll go through a PowerPoint presentation. Then we'll review, take a quiz, and then we'll watch another short video.
You've no doubt heard the term hazard communication and the acronym MSDS, short for Material Safety Data Sheet. The Hazard Communication Standard requires employers to train employees about the hazards of chemicals and substances in the workplace. In 2003, the United Nations adopted the globally harmonized system of classifying and labeling chemicals. Here's a new acronym you'll be hearing a lot more in the future: GHS. The GHS includes criteria for the classification of health, physical, and environmental hazards, as well as specifying what information should be included on labels of hazardous chemicals, as well as safety data sheets. Since 1992, the United Nations have been working to create and enhance a globally harmonized system for the classification and labeling of chemicals that can be used by importers, distributors, and manufacturers worldwide. The United States was an active participant in the development of the GHS and is also a member of the UN bodies established to maintain and coordinate implementation of the system. The Occupational Safety and Health Administration, or OSHA, has mandated changes to the existing hazard communication standard that adopt the globally harmonized system. In this video, we'll go over information about the new globally harmonized system of hazard communication. Specific changes to be discussed include new container label formatting, product identifiers, signal words, pictograms, hazard statements, precautionary statements, and safety data sheets. On or before June 1st, 2015, all of the following changes to the Hazard Communication Standard will take effect. Material Safety Data Sheets, or MSDS, will become Safety Data Sheets, or SDS. The new SDS will serve the same purpose as the old MSDS. The SDS will be in a standardized format and easier to read. Labels on hazardous chemicals will include pictograms which visually identify the main hazards. Signal words will be required on all labels where hazards exist. The signal word warning will indicate less serious risks, and the signal word danger will indicate more serious risk. Hazard statements will be required on labels to explain what the hazard is. Precautionary statements will be required to explain what you should do to protect yourself from the hazard. All labels will be required to have pictograms, a signal word, hazard and precautionary statements, the product identifier, and supplier identification. Labels will vary but must still contain all the following elements. Product identifier. This can be the chemical name, code number, or batch number. The manufacturer, importer, or distributor can decide the appropriate product identifier, but the same product identifier must be on both the label and in Section 1 of the SDS. There are two signal words in the GHS system: danger and warning. These signal words are used to communicate the level of hazard on both the label and the SDS. The appropriate signal word to use is set out by the classification system. For example, the signal word for self-heating substances and mixtures, Category 1, is danger, while warning is used for the less serious Category 2. There are occasions where no signal word will be called for. The GHS will require pictograms on labels to alert users of the chemical hazards to which they may be exposed. Each pictogram consists of a symbol on a white background framed within a red border and represents a distinct hazard. The pictogram on the label is determined by the chemical hazard classification. There are 8 pictograms required by the new standard and 1 that is optional. The health hazard pictogram is used for chemicals that pose a risk to your health if used improperly. The flame pictogram indicates there is a risk of fire, and you should be especially concerned about ignition sources and combustible materials. The exclamation mark pictogram will usually be used in combination with a health hazard pictogram to signify particular health risks which are less severe than the skull and crossbones category. The skull and crossbones pictogram will usually be used in combination with a health hazard pictogram to signify particularly hazardous chemicals. Chemicals with acute toxicity are chemicals that will produce adverse effects following a single dose of the substance. The gas cylinder pictogram alerts you to the physical hazards inherent in the use and storage of compressed gas. The corrosion pictogram should prompt you to be especially aware of PPE and storage requirements. Chemicals marked with an exploding bomb pictogram pose a significant physical risk and should be treated with extreme caution. Oxidizers are chemicals that produce additional oxygen in an environment which may cause or contribute to the combustion of other materials. These chemicals will be indicated with a flame over circle pictogram. The environment pictogram is a non-mandatory category. I've included it here for your information. Hazard statements are used to describe the nature of the chemical hazards, including, where appropriate, the degree of hazard. All of the applicable hazard statements must appear on the label. Hazard statements may be combined where appropriate to reduce redundancies and improve readability. Precautionary statements are defined as a phrase that describes recommended measures that should be taken to minimize or prevent adverse effects from exposure to hazardous chemicals or improper storage or handling. The new GHS standard requires that chemical safety data sheets consist of 16 specific sections. Section 1, Identification, includes product identifier, manufacturer or distributor name, address, phone number, emergency phone number, recommended use, and restrictions on use. Section 2, Hazard Identification, includes all hazards associated with the chemical and required label elements. Section 3, Composition Information on Ingredients, includes information on chemical ingredients and trade secret claims. Section 4, First Aid Measures, includes important symptoms, effects, acute, delayed, or required treatment. Section 5, Firefighting Measures, lists suitable extinguishing techniques and equipment, chemical reactions as a result of fire. Section 6, Accidental Release Measures, lists emergency procedures, protective equipment, proper methods of containment and cleanup. Section 7, Handling and Storage, lists precautions for safe handling and storage, including incompatibilities. Section 8, Exposure Controls and Personal Protection, lists OSHA's permissible exposure limits or PELs, threshold limit values or TLVs, appropriate engineering controls, and proper personal protective equipment. Section 9, Physical and Chemical Properties, lists the chemical's characteristics. Section 10, Stability and Reactivity, lists chemical stability and possibility of hazardous reactions. Section 11, Toxicological Information, includes routes of exposure, related symptoms, acute and chronic effects, and numerical measures of toxicity. Section 12, Ecological Information, provides information to evaluate the environmental impact of the chemical if it were released to the environment. Section 13, Disposal Consideration, provides guidance on proper disposal practices, recycling or reclamation of the chemical or its container, and safe handling practices.
So now we're going to go through the PowerPoint presentation, which you should all have printed out. And you can take notes as I go through this, and then use those notes when we take the quiz. It's only about 10 questions, but I'll call out the things that we're going to talk about, or what's on the quiz, and you can take notes or circle the information in there just so you can use it.
Product that is not indicated anywhere else on the SDS. Section 16, Other Information, includes the date of preparation or last revision of the SDS. For more information on the globally harmonized system of classification and labeling of chemicals, visit this website.
So what does hazard communication and the global harmonization system have in common? They're the same because at WACS you have the right to know and understand what chemicals are in your facilities. The purpose of MIOSHA's right to know law is to make sure that needed information reaches all employees and workers who use hazardous materials. So today's topics, we're going to talk about why we use GHS, who receives training, NFPA and HMIS labels, our use of chemicals in the HazCom plan, transportation, receiving, handling, and labeling, shipping labels, workplace labels, SDS sheets, testing for hazardous conditions. We're actually going to go over safety awareness and then review for the quiz, and then we'll watch the high-low awareness video, and that'll be the end of my section. So why we use GHS? Adoption of the global harmonization system is to improve health and safety of our employees. The U.S. adopted GHS from international regulations. It's a more standardized approach to classifying chemicals for better conveyance of information. Helps improve information received from other countries. Minimize the confusion of chemicals crossing the borders. We'll always have consistent information. So specifically at LACS, at most facilities, we get a lot of chemicals from all over the world. Europe, Africa, Asia, South America. The way SDS sheets and chemical handling was handled previously, so you get a chemical, you get an SDS sheet with it. If you need to know where the first aid information is on that SDS sheet, it might be on the last page, it might be on the first page. You have no idea. It varies from manufacturer and country of origin. Well, now, globally, every SDS sheet is made the same way, regardless of who manufactures the chemical or where it comes from. So you always know that wherever you find a chemical, if you're looking at an SDS sheet, Section 4 is always first aid. All chemicals should be coming into companies with GHS labeling, so this is a relatively new system. It just started in 2016. And it was a slow kind of progressive step-by-step process, but now everything should be GHS compliant coming into our company. Chemical information found in the SDS under GHS, so the GHS has a lot more information now than it's required to have a lot more information than it did before. SDS stands for Safety Data Sheet. That is in the quiz. SDS stands for Safety Data Sheet. It used to be Material Safety Data Sheet, so if some of you have worked in manufacturing previously, you might have heard that before, MSDS, but now it's SDS, Safety Data Sheet. Safety Data Sheets can be found on MSDS Online. We'll talk about that shortly. That's our online repository for all of our SDS sheets for all the chemicals company-wide. Who receives training on hazardous chemicals? Everyone. All employees must be trained to detect hazardous chemicals that are released in the workplace. This is on the quiz. Retraining may also be required if an individual changes job duties, a new chemical or hazard is introduced into the work environment, or if it's determined that the initial training was deficient. So that is on the quiz. Workplace labels. Have a couple examples. This is an NFPA label, or National Fire Protection Association. You'll still see both of these. This particular label you might see on the outside of a building here, or any manufacturer. The fire department still likes to see these. And then you might see an HMIS label as well, maybe on a chemical that we've had for a long time. Procured it before GHS regulations came into play. We still have it, we don't use it as much, so sitting somewhere you might see one of these labels or one of these. You just need to remember that 4 is higher on these labels, so that's pretty high for flammability. This one's pretty low for reactivity. So the numbers are reversed in GHS, so you just have to keep that in mind. GHS example of a workplace label. Workplace labeling provides at least general information regarding the hazards of the chemicals. We're going to go through one of these shortly. Our use of chemicals in the HazCom plan. We have around 6,000 chemicals in our inventory. Most of them are from our platers, paint facilities, and our corporate lab. But our molders, assembly, distribution, and our support facilities also have chemicals. The HazCom plan is a list of chemicals in our facilities. Each facility individually has one. If you want to see that, you can ask your SDS coordinator, supervisor, or designate. It's available on the information board, which we'll cover shortly. And you can also find it on MSDS Online. You have the right to request a copy of an SDS. So, with MSDS Online, when you get to your plant and you're doing your on-the-job training, they're going to show you, every break room has a kiosk computer. Most of the time people use it for HR stuff. You can get your pay stubs and check your insurance and things like that. But you can also access MSDS Online, which is where we have all our SDS sheets. So they're going to show you how to look up an SDS sheet. If you're working with formaldehyde and you want to see the SDS sheet, they're going to show you how to look it up. So you can find it anytime you want. But you also have the right to request a copy of it. So if you forget, you don't have time to look it up, all you need to do is say, I'm working with this chemical, or I'm working with this product, this spray paint. You talk to your supervisor, you say, I want to see an SDS sheet, they will get it for you. You have the right to see that, look through it if you want, if you feel, your health might be at risk or something like that, or you just want more information, just bear that in mind. They're going to show you how to look it up on your own, so you can do it on your own time, but you have the right to request that. So transportation, receiving, handling, and labeling. DOT regulations apply while shipments are on the road. The DOT says you must have the correct placards on all 4 sides of the truck. SDS is always on the driver's side door for all the chemicals in the truck, and everything should be secure. Once a truck arrives at LAX, that's when GHS regulations apply. As I said, we get chemicals from all over the world. They must have a GHS shipping label and they must provide an SDS. This part is on the quiz. The SDS is not required to be physically attached to the item, nor required to be sent again each time the employer reorders the same chemical. So we go through a lot of nitric acid here at our plating facilities. We order a lot of it. Haviland sends it to us. Unless something changes, they don't technically have to resend it every time they send us nitric acid week after week after week. Typically they do, just because it's like a habit probably for them as they're shipping out chemicals, but it's not required. If the shipping label is damaged or we don't have an SDS sheet for that chemical, we can refuse the right, we reserve the right to refuse that shipment. We can turn it away and send it back, because if we allow that chemical into our facility and we don't have an SDS sheet or we don't have a label, now we're liable for that chemical. Shipping labels. There's a couple shipping labels that are used here at LAX. They're both GHS compliant. There's only one difference, and that's the DOT label here on this label. So it's just an added bit that some companies put on their GHS labels. It's helpful, it's nice to have, but it's not required. So number 1, the product identifier. It's the name or the product of chemical. It includes numbers, cast numbers, and other identifiers, and it links the hazardous product to the shipping label, SDS, and the HazCom plan. So it needs to be very specific. If you're working with a product, say you're working with formaldehyde, which you're probably not going to be doing, but if you were, and you wanted to see the SDS, you would look at the label and you would see that it said formaldehyde, and then you would look it up on SDS Online, MSDS Online, and find the SDS for it. And you want to make sure it just says formaldehyde, because right next door, somebody might be working with formaldehyde 1,2,3, which is a different mixture. It's slightly different, so the SDS is going to be different. So this product identifier will be the same across the board. There might be numerical differences from product to product, but you know that what you're looking at, what you're working with, you look it up on the MSDS Online, that's the product you're working with. Signal words. There are only 2 signal words that are allowed under GHS: danger and warning. Caution used to be used. It is no longer allowed. And there are only the two words, danger and warning, are the only words allowed. So there will only be one on the label. If no hazard exists, there will be no signal word. So it will be danger or warning or nothing. Okay. Number 3, hazard statements. Describe the hazards associated with the product. Some examples include fatal if inhaled, highly flammable, may cause drowsiness or dizziness. Describe the nature and the degree of the hazard. In our example, highly flammable liquid and vapor causes serious eye damage, may cause drowsiness or dizziness. Number 4, precautionary statements. These are predetermined statements by OSHA. You should read these before handling the product to prevent any effects from exposure. On the GHS label, it describes the measures to be taken to prevent exposure or injury from a chemical. In our example, keep away from hot sparks, open flames, hot surfaces, no smoking. Avoid breathing fumes, mist, vapors, etc. Number 5, supplier identification. Some elements that may be included are address, telephone contact, emergency contact, email, website, fax number. And finally, section 6, the pictograms. Intended to display specific hazards visually, always inside a red diamond. The shipping label can include one or more, and can also be found on section 2 of the SDS. In your handout, if you turn the page, there's also a listing of those. If you want to go over those in your own time. But I do want to call out a couple. Flame over circle and flame. Flame over circle, that means an oxidizer, okay? This is just a flammable, flame flammable. So those get confused occasionally. So a little device you can use, flame over circle, circle O oxidizer, okay? And then flame, no circle, just a flammable. All right, SDS sheets. All SDS forms contain the same information in the same order. I believe that is on the quiz. Section 1, identification. The product identifier, a distributor name, address, phone number, emergency number. Section 2, hazards identification. Physical hazards, health hazards, and other. Examples of other include OSHA hazard communication standard information, GHS label elements, and pictograms, as well as the signal word. Section 3, composition information. The chemical ingredients, any trade secrets. So, again, if you were working with nitric acid and it was pure nitric acid, it might say 100% nitric acid. But if you were working with a manufactured chemical or a product like Windex, there would be maybe 15 or 16 different chemicals in that product. So then the SDS sheet's going to break it down by percentage what's in that product. Section 4, as I alluded to earlier, is always first aid measures. Acute or delayed symptoms and effects, required treatment. Section 5, firefighting measures. Extinguishing techniques, equipment, chemical hazards. You can't put every fire out the same way. So this information is there mostly for first responders in case of an emergency. Section 6, accidental release measures. Proper methods of containment and cleanup. So this is on the test. The SDS sheet will tell you how to properly clean up a spill if you have one. Section 6, that's what it's there for. If you have a spill, that's the first place you should look for information. That being said, it's not always that helpful. A lot of times you go to section 6 and it just says follow proper procedure or local regulations when cleaning up the spill. They'll point you to other regulations to read. But on occasion, you'll find one that will tell you what absorbent you should use and what you should do with the waste absorbent when you're done, how you should package it up, where you should send it, how it needs to be handled as a waste. So on occasion they are quite helpful, but not all the time. Section 7, handling and storage. Any storage precautions or incompatibilities if a chemical needs to be kept below a certain temperature or away from another type of chemical. Section 8, exposure controls and PPE. The permissible exposure limit, the threshold limit value, engineering controls, PPE. We'll cover that shortly in a few slides, but that information is found in Section 8. Section 9, physical and chemical properties, the chemical characteristics of the product. Section 10, stability and reactivity. Section 11, toxicological information, routes of chemical exposure, related symptoms, both acute and chronic. Some examples of chemical exposure include ingestion, inhalation, skin absorption, or a puncture injury. All of those, that's in the test, so you want to take note of that. Those are all examples of chemical exposures, or routes of chemical exposure, possible routes. Section 12, ecological information. Section 13, disposal considerations. 14 is transport information. 15, regulatory information. And 16, other. Anything that didn't fit into the last 15 sections, they put in section 16. Testing for hazardous conditions. We have specialists that test the air for contaminants, and proper precautions are taken using the hierarchy of controls if necessary. So depending on the facility in which you're going to work, you may eventually see somebody wearing a pump like this, or like this, or a badge like this, or using a meter, or a gas tank, or something like this. And what that does is it measures certain chemicals in the air. The government says you can only be exposed to certain levels of certain chemicals. Some of which those chemicals we use, so we need to test the air and make sure our employees are safe. So we do the testing, and if we find a problem, we use the hierarchy of controls to kind of figure it out and deal with it. The most effective thing we can do at the top is elimination, physically remove the hazard. We have a pretty specific process. So elimination always goes hand in hand with substitution. We can't just take away part of our process. We have to substitute something else. But that is the most effective. Down a little lower, we have engineering controls. Isolate people from the hazard. So a physical barrier, a fan, an exhaust fan, a downdraft table, something like that, to keep you physically away from the hazard. Moving down, we have administrative controls, change the way people work. We might say, if you're a painter, a spray painter, you can only spray for 20 minutes and then you've got to take a 5-minute break. And then you go back and you spray for another 20 minutes and then you take another break. And back and forth throughout the day. And then the least effective is PPE. That's personal protective equipment, things like a respirator or a dust mask or something like that. The reason it's the least effective is we're now relying on you to make sure that you're being safe. We have only limited control over that. We can give you a respirator, we can train you how to use it, but only you can put it on properly and make sure you're wearing it when you need to. So that's why that's considered the least effective. Now I've said all those things, all the testing that we've had, we have a very safe work environment. We don't have to use the hierarchy of controls. Quite rarely we actually do something about the hazards we have because they're very low. We have a very good system in place, so I want you to be aware of that. But we continue to test annually. Every facility where we have any type of hazard, we still test. All right, right to know boards. So typically outside of the break rooms, there's a series of boards listed or put up. There's one for safety, one for environmental, one for human resources. The Right to Know board has information about plant maps. That's like right here. Plant maps will have your fire extinguisher locations, spill kit locations, severe weather shelter areas, emergency exit routes, employee congregation areas, eye washes and showers, hearing protection areas. So that'll all be marked on there. But then the Right to Know board will also have meeting walkthroughs, your CPR, bloodborne certified people, information on confined spaces, all the important safety information that you're supposed to have. Lockout, tagout awareness. A majority of our facilities use robots in some capacity. Those robots are usually blocked off from access with these blue kind of fencing gate things. And there's always signage, caution, stay out, things like that. Never under any circumstances shall you ever enter a dangerous area that has a caution sign. Lockout, tagout must be in place before working around robots, and only trained, authorized lockout, tagout personnel are allowed to enter these dangerous areas. This is kind of, this is a picture of the lockout, tagout process. If you're not familiar, if you picture this as the main power source for a robot, they turn it off, and they put this hasp on there. And then Joe's gonna work on the robot, so he puts his lock right here, so nobody can turn it back on. So he's in there working, and then Bob comes over, and he's gonna work too, so he puts his lock right here. Joe comes out, he's done for the day, so he's gonna take his lock, but you still can't turn it on, because Bob's lock is still sitting here, so still nobody can turn it on. Bob goes home for the day, takes the lock off, turns the power back on, and you're good to go. All right? You'll get trained on that. If it's going to be part of your job, you'll get more information than my little 3-second briefing there, but that's kind of the gist of it. So just be aware of these caution signs and stay out of those areas. Confined space. Several of our facilities have areas that are large enough for an employee to fit into, not designed for continuous human occupancy, and have limited means of entry or exit. Only persons trained in confined space, entry and lockout, tagout can enter these spaces. Some examples are plating tanks, storage tanks, silos. So you'll see these signs and just be aware of them and stay out of those areas unless you have a confined space permit and have been trained. Machine guarding. MIOSHA requires that parts of equipment which transmit power be safeguarded so that employees do not become entangled, pinched, or caught in moving parts, kind of like this guy and his poor beard caught in this, looks like a grinding wheel. Belts and pulleys, flywheels, chains, sprockets, and gears must all be guarded. Our safety specialists inspect new machinery before it's installed in our facilities to make sure that MIOSHA requirements are met and surpassed. So again, keep an eye out for those caution signs, those warning signs, just be aware of them. And ergonomics. Ergonomics is the art of fitting the person to the machine. No two people are the same, however job expectations are. The safety department personnel look at the ways in which people do their jobs and tools and equipment they use, and injuries that may be associated with ergonomics. Musculoskeletal disorders are conditions where part of the musculoskeletal system is injured over time. Musculoskeletal disorders can affect the body's muscles, joints, tendons, ligaments, and nerves. Basically, lift properly. If you're going to be working in a job where you got a lot of repetitive bending and twisting, and probably not twisting, but bending over, lifting, and things like that, typically we have adjustable surfaces and things to help with those jobs. We have cranes next door for helping with lifting heavy wheels. Our racks for the plating line are adjustable, so if you're placing parts on the racks, they move up and down, so you're not reaching or bending over too much. We have tables that go up and down. So if your job involves that type of work, and we have those things in place for you, you need to be using them to avoid musculoskeletal disorders. First aid, CPR, and bloodborne pathogens. In all facilities, there's a posting that identifies the first aid, CPR, first responders. Every shift at every facility has to have at least one person that's CPR first aid trained, as well as bloodborne pathogen. Bloodborne deposit boxes are located in the bathrooms, and the first aid kit, bloodborne kit, and sharps container will always be located by each other. And finally, our mission statements. Our environmental policy to continually improve at minimizing the environmental impacts of our products and operations through pollution prevention and conservation of materials and natural resources, and to ensure a safe environment for our employees, customers, and the public. Our health and safety policy to provide a healthy and safe work environment for our employees and protecting our customers and the community through a comprehensive occupational health and safety program that meets or exceeds regulatory specifications. All right, so number 7, SDSs must be physically attached to each chemical shipment, including reorders of the same chemical. True or false?
True.
False. It does not need to be on every reshipment, reorder. Number 8, the SDS tells you how to clean up spills or leaks. True or false? Sorry, true, yes, true, correct.
What you're watching is a recreation of a mishap involving a forklift and a pedestrian. From this viewpoint, there doesn't seem to be a logical reason why this mishap occurred. The pedestrian is walking along a marked walkway in plain view. The forklift isn't carrying a load that would obscure the driver's view. However, when the camera is set up to catch the driver's view of the same scene, all that shows up is an empty walkway, until it's too late. There are 2 important points to be made from this incident. 1, a pedestrian can't assume the forklift driver sees him or her, and 2nd, they can't assume a forklift is just like any other vehicle. These points are important to make because of the very large number of mishaps that occur. Tens of thousands of pedestrian injuries are caused by forklifts every year in the United States. Measured against that, there have been no reports of injuries to forklifts from running into pedestrians. To help understand why all these injuries happen, we should go back and look at the assumptions. People tend to assume that forklifts are just like other vehicles, including the one they drove to work that morning, except maybe a bit more nimble since they zip back and forth. And that implies that they aren't especially heavy. It also assumes that they steer and move like automobiles and can stop as quickly. People also assume that, like the other vehicles they're familiar with, forklift drivers can see just about everything around them. The fact that none of these assumptions are true is what gets those tens of thousands of pedestrians injured each year. Take the assumption about what forklifts weigh, for example. Even without a load, they're a lot heavier than they look. This forklift, even empty, weighs about the same as these 2 automobiles. To allow a forklift to carry a heavy load up front, each one has a heavy counterweight in back. On this model, the counterweight alone weighs close to the same as a small pickup truck. An electric forklift has a smaller counterweight because the battery provides part of the weight. We staged a demonstration of how heavy a forklift battery can be. They didn't even get the full weight of the battery on the back of the pickup before it started to lift the front wheels off the ground. And carrying a load, of course, forklifts are even heavier. This concentrated weight translates into much more severe injuries to pedestrians, much more than people would predict would happen if they hadn't seen the actual results. To illustrate this, we reenacted another mishap, an example of the 4th leading cause of pedestrian injuries, being pinned between a forklift and something else. The driver checked to the right, then backed out. The pedestrian was just coming out from between other forklifts. If this were to happen with a passenger car, it would be a very nasty injury. But to visualize the kind of injury from a forklift counterweight, we replaced Debbie with a turkey drumstick, and she wasn't insulted. Here the forklift is traveling slower than it did in the actual mishap. That's simply too much damage to ever heal. That's why so many pedestrians struck by forklifts have to have limbs amputated. Here's another reenactment of a pedestrian forklift mishap. This incident led to the pedestrian having their foot run over, the ninth leading cause of pedestrian injuries from forklifts. This time, we replaced Debbie with a red trash can before the forklift started up again. And now we'll use a pair of drumsticks to replace her feet, to show the effect of being run over by a forklift. Again, if we judge by what would happen if this injury came from a heavy vehicle, we'd predict a nasty injury, some surgery, some weeks, and a cast. But the same mishap involving a forklift? Notice in the drumstick run over by the forklift, part of the bone is simply missing. Severe enough damage that it probably leads to an amputation. There's another point to make from this reenactment. A characteristic of powered industrial trucks, forklifts, that increases the chances of one hitting a pedestrian is the way they maneuver. People are used to seeing how cars turn a corner. The front end swings around and the rear follows the same path. But the steering wheels on a forklift are in the rear, so when they turn a corner, that heavy back end swings out. Many of the pedestrian injuries, the struck by and the pinned between forklift and something else, happen this way. Related to that weight and maneuverability is the fact that powered industrial trucks simply can't stop as quickly as other vehicles. Of course, these characteristics don't exist out there just by themselves. They team up with those very bad sight lines to create the severe hazard to pedestrians. To help people appreciate how limited the forklift driver's vision can be, we set up a display at our forklift rodeos. We encouraged people to sit in the driver's seat to spot the pedestrian. It's a very worthwhile exercise, one that any employer could easily duplicate to help create a safer workplace. So these are some of the characteristics of forklifts that contribute to the number and severity of injuries to pedestrians in the workplace. The other causes of injuries have to do with where and how forklifts are used in the workplace. The pace of work, the repetitive nature of work, and unlike other vehicles, they share the workplace with pedestrians, and that leads to complacency and familiarity. And again, pedestrians don't understand how limited the sight lines are from a forklift. Pedestrians struck by powered industrial trucks are the most common causes of injuries. However, there are two other causes that bear mentioning here. Powered industrial trucks striking an object which then strikes a pedestrian. For example, knocking things off the top of a stack or knocking the whole stack over. A load fell or lowered on or pinned a pedestrian. The purpose of this presentation has been to increase people's awareness of the hazards presented by sharing the workplace with forklifts. To help translate this awareness into your own personal safety, we'll give you 5 rules to remember. Never assume the driver sees you. If you can't make eye contact with the driver, you're in a dangerous position. Keep looking around. Always look both ways. Give forklifts room and just stay away from them. Every company is supposed to have rules for forklift drivers to follow. Protect pedestrians, enhance safety. But rules by themselves can't protect pedestrians from injury or death. Because even if the rules say that the driver is always at fault in a collision with a pedestrian, the drivers are always the ones who get to walk away uninjured. Thousands of pedestrians each year are not that lucky.